Guys, I just wanted to go over some problems with you for density calculations, do a little review, and then kind of talk about how to organize and think through these density calculations. Okay? Now, if you organize your work and you decide what numbers are before you get started, you should be able to do these problems with no problem. Okay? Now, here, I like a review, like density is really how tightly packed things are. So, you see these boxes here. See this? Low density would be the one that's all, on the left, high density on the right. Okay? Why things sink and float, that's also a density property. Okay? And then, of course, our little triangle here, and I'm going to show you all these applications. Okay? Um, kind of all these applications. So at any rate, let me proceed on to show you how to do these calculations, all right? All right, so here we go. Let's do some review. Density is a relationship between mass and volume. It is the ratio between those two things, between mass and volume, okay? How much bigger is the mass to the volume, or vice versa? How much smaller is the mass to the volume, okay? All right. Now, just also think of this. The ratio is the amount of stuff in each amount of volume. Okay, so that in that volume or space. Okay, so just substitute the words that we've learned for those things. It is a derived unit. It has more than one unit. It is from more than one thing. This particular property has two units. Okay, and we've been using the mass unit and volume unit of grams over milliliters or grams over centimeter cubed. Two units. Anytime you say density, you have to write two units, one mass unit and one volume unit, okay? Because that's where it comes from. All right. It is an intensive physical property, meaning that the value of the density does not change with the amount of substance. Therefore, every substance has one and only one density and can be used to identify the substance. They use it in forensics, they use it in building materials, they use it for all sorts of things. When they got an unknown substance in a mine, they'll use it to identify what metals are in the mine or whatever, okay? Density is an identifier. Okay, so here's this triangle that we've been using, and I'm just going to go quickly over how to get these formulas using this triangle. Okay, so first thing is, let's go through these formulas. All right, say I want density. All right, so what do? What is the density formula? You cover up density and you write what's left. So what is the density formula? Hopefully you wrote density is mass over volume. Okay, all right. Well, now let's go to the next one. Let's see for mass. Okay, we'll cover up the mass. And you tell me now what's the mass formula. And hopefully you put density equals density times volume. Okay, that's how you get mass. All right, and the last one is volume. Okay, cover up volume. All right, what do you have to calculate volume? And hopefully you saw it there. It's mass divided by density. Okay, see, it's what's left over that's where you get your formula from. That's how you use that triangle. Okay, all right. So density is used to determine if the material or substance is good for the job it is built for. All right, I'm going to give you an example of this. And this is an actual example. All right. So for example, if you want to build a boat out of wood, wouldn't you want to know if the wood floats on water? Okay. So you need to know the density of that wood to see if it would. All right. A boat builder likes to make special boats out of reclaimed wood from trees he finds at the bottom of lakes. He found a particular tree, but he did not know what type of wood it was and if it would be a good density for his boat building. So he cut a piece of out of the tree that had the dimensions of 1 meter by 0.5 meters by 0.25 meters, and a mass of 159.4 kilograms. Would this wood be good to use for his boat? The density of water is 1,000 kilograms per meter cubed. Now, you have several numbers here, okay? Now, this is what most students do. They see all these numbers, and what they do is they just put it in their calculator, multiply them all together, and say, maybe that'll work. Well, that is not thinking through a problem, okay? You got to know what the numbers mean, all right? What the goal of the problem is. We want to know if this boat floats. So for it to float, it would have to have a density that is less than water. So we need to find the density of the wood first and then compare it to the water. Okay? That's what we are doing here. So we need to find the density of the wood and then compare it to that of the water. All right, so here is our triangle. Okay, I want you to figure out what formula would we use. We want to get the density of the wood, and I just showed you how to get those formulas. Okay, so hopefully you covered up the D because we're getting density, and you see what's left? Hopefully you put down density equals mass divided by volume. Okay, so now we need to get the mass of the wood, right? So we're going to write mass of the wood, and it says it up there, is 159.4 kilograms. Now, this is not grams, it's a form of grams, but kilograms is a mass unit, okay? You need to know your units. I don't know how else to say that, but you need to know your units. Mass is grams, so anytime you hear anything with grams, kilograms, centigrams, decigrams, it is mass, okay? Now, the other thing you need is volume. So somewhere in this problem, there must be volume. Now, hopefully you remember from the chocolate candy lab, that volume, well, you should know this from your math class. Volume is length times width times height. Do you have something there that's length times width times height? I hope you recognize that as this. So you have to recognize things for what they are, okay? So that is the volume. So I'm going to put those numbers down. 1.0 meters times 0.5 meters time, nothing new, right? You learned this years ago, that volume is length times width times height. Okay, now it's just like going x times x times x, all right? It's going to turn into meters cubed, right? So when I do that, I get 0.125 meters cubed. How do I know? There's 3 meters there, and they're being multiplied together. Just like x times x times x, x would be x cubed. This is meters cubed. All right, so I have mass, and I have my volume. And I labeled everything so I know what the numbers mean, okay? Well, mass goes on top, so I'm going to write that number first. So D equals 159.4 kilograms. See how this is all organized, and you can follow it, all right? Over, and now make sure you use the right number because this is it, 0.125 meters cubed. Now look, 2 units here. They don't cancel out, so you got to write both of those units. All right, now when I go ahead and divide these two things, I get a density of 1,275 kilograms, see they don't go away, per meter cubed. Now, yes, I do want to know the density of this wood, but now I want to compare it to the water, all right? So here it is, it's asking, here's the second part of the question, it's asking, would this be good for the boat? In other words, does it have a density that is less than 1,000 kilograms per meters cubed, because the density of water is 1,000 kilograms per meter cubed, and to float on water, it has to be less than that. Okay, so you tell me, will this boat float, or is it going to sink? Well, hopefully you realize that 1,000 kilograms per meter cubed is definitely a lot smaller right, than 1275 kilograms meter cubed, which we just calculated. 1275 kilograms per meter cubed is more dense. It's a very heavy wood. Matter of fact, it's probably the second most dense wood that known to man. And that boat would definitely sink because the density is greater than water. And bye-bye boat. That's why it was found at the bottom of the lake and not on the top. Okay? Well, one good reason. All right, so there we go with that. All right? Okay, so there's one problem, and that's how you would think through all that. All righty. Hopefully you understood all that. Okay, here's another one. Jenny had this fiance that gave her a silver ring for their engagement. He claimed that it was pure silver. Being the scientifically minded girl that she is, she decided to check to see if her boyfriend was telling her the truth. She first took the ring's mass, and it was 70.1 grams. Then she got a graduated cylinder and filled it with a water level to 35.4 milliliters. She then placed the ring in the cylinder and the water level rose to 42.7 milliliters. This should be very familiar. We did do this in class in our volume activity. So hopefully you remember that. If the density of pure silver is 10.5 grams per milliliter, should she hug her boyfriend or throw the ring at him? Now, again, you see all these numbers, 70.1, 35.4, 42.7, 10.5. Okay, don't be the typical teenager and just plug those things in your calculator, multiply them all together and say, hey, that's it. No, that is not. What is the goal of the problem? That's what you're deciding first, okay? The goal of the problem is to see if this is pure silver. And remember, all substances have one and only one density. So if the density is not 10.5 grams per milliliter, which is pure silver, it is not silver. So we need to get the density of this object, this silver object that looks silver, but it may not be pure silver. So we need to figure out the density of this object to see if she's going to hug her boyfriend or throw the ring at him. Okay, so there's our triangle. Okay, you're going to cover up the density. Tell me what is the formula you're going to use. Okay, so hopefully you wrote density equals mass divided by volume. That's what it says, right? Okay, now we need two things. We need mass, and it says it. The mass was 70.1 grams, so I'm going to write that. Again, organize your work. The more you organize your work, you guys will all get A's in math if you just organize your works and know what the numbers mean before you start, okay? The next thing we need is volume. Well, volume is not 35.4 milliliters, and it's not 42.7 milliliters. What do we want to know with the water? We don't want water. That's the level of the water. That's not the space that, right? Volume is space. It's not the space that that ring takes up. The space that that ring takes up, remember doing this, is 42.7 minus 35.4 milliliters. So if I take those and I subtract it, I get 7.3 milliliters. Now I have what I need. I have the mass and I have the volume. Okay? Now I'm going to plug in my numbers. So there it is over there. Density equals mass over volume. Now look, how many units are here that don't cancel out? 2, right? So after I divide those numbers, keep those units there. 2 units. All right. So I'm going to divide this out. And if I do that, I get D equals 9.6 grams per milliliter. 9.6 grams per milliliter is definitely not 10.5 grams per milliliter. So I would write 9.6 grams per milliliter is not 10.5 grams per milliliter. Yes, they would have to be exact. It's not even close. That's not pure silver. Whatever it is, it's not pure silver. Okay? So therefore, since the densities don't match, guess what she's going to do with that ring? Well, hopefully you figured it out. she's going to throw that thing at him, okay? Because he did not tell her the truth. It's important to tell the truth. Okay, so here we go. Now, here's another one. A backpack full of pure gold. Can you imagine that? You would just retire for 3 lifetimes. Has the dimensions, the backpack has the dimensions of 42.4 centimeters by 33 centimeters by 21.6 centimeters. Hopefully you noticed by now that that is the volume, right? Length, width, height, okay? If the density of gold is 19.3 grams per centimeter cube, okay? What is the mass of that backpack? All right, now, so we have our triangle here, and we want to figure out mass, so we're covered up mass, and I don't know why density times volume came up there, but at any rate, we got mass equals density times volume. It came up a little early, but at any rate, there it is. That's what you would use. Okay, now, so the first thing we want to know is what is the mass of this backpack. So we're just going to plug numbers in. All right, now I'm gonna put things over here. We want to know the density because we're getting the mass. So density equals 19.3 grams per centimeter cube. Okay, but we also need to know volume because that's what it says over there. Well, we know volume is length times width times height. And if I put those together and get the volume of that, I get 30,000. No, yeah, this is what I get. 30223. Whoop, sorry, that's a 2. All right. Now, what would be the units here? Hopefully you said, hey, I see 3 centimeters and they're being multiplied together. So that would be centimeters cubed. Volume is always cubed, okay? All right, so now I'm going to put it in there. I have my density. So mass equals my density, 19.3 grams per centimeter cube. Remember, 2 units times my volume, 30223 centimeters cubed. Okay, now what actually happens is the centimeters cubed actually cancel out. But our interest is in the mass. Oh, this mass is huge. It is 583,298 grams. Now that is a lot. All right, so there's the mass in grams. It's a lot. Well, let's put some perspective on this thing, okay? Well, if there are 1,000 grams in 1 kilogram, how many kilograms of mass does this backpack have? All right, well, here it is, 583,298 grams. All right, well, it says I have 1,000 grams in 1 kilogram. All right, that'll help me to cancel out because I'm dividing the grams. Cancel out the grams and I have kilograms. So now I'm going to divide those two numbers. So I have 583,298 grams divided by kilograms, I'm sorry, because the grams I just told you canceled out. So let me erase that. Alrighty, kilograms over 1,000. And if I do that, this equals 583. Now, I'm going to round it, okay, to that decimal place, okay, because it would actually be 0.298 kilograms, which I'm just going to round to 583 kilograms, okay? All right, now, here's the next question. Okay, I'm going to move this over so you guys can see this. So I have the 583 kilograms. 583 kilograms is the backpack of gold. All All right. All right. Now, an average, and this is true, the average mass of a 15-year-old teenage boy is 56 kilograms. Okay, that's about 112 pounds or so. So they're kind of small when they're 15. Okay, so we want to know how many times bigger this is. So what do you do to figure out how many times bigger something is? You divide. So I'm going to divide by that 56 grams. All right, I'm going to divide this 56 kilograms, and if I do that, I end up getting about 10 times more or heavier. That backpack of gold is about 10 times heavier than the average teenage boy. So if I say that you would be able to retire for 3 lifetimes, that would be true. Okay? All right. So hopefully that helped you in how to evaluate and set these problems up and to think them through and how you would use density. Okay?